Welcome to the 6th mini lesson. This time we're going to talk about how to randomize your problems. There's different ways to do that. So let's just go ahead and get started. I'm in my construction space and I'm going to create a new problem and I will call it randomization. Okay, we'll hit continue. Just so you guys can get a good idea of how to do this on your own, I'm just going to start with a blank problem. Alright, so here we go. Alright, so I'm going to hit edit, look at it this way again. First of all, let's go ahead and plan on making a problem where you're going to ask the student to do a hypothesis test using a t-statistic. Okay? So first thing, you want to add a problem part. Let's just go ahead and assume that we're going to have a multi-part problem. Okay? So save and edit. All right, call it part A. Okay, so we'll want a numerical response because they'll be typing in a number for the t-statistic. Save and edit. All right. So let's just go ahead and clean this up. I know I'm not going to care about significant figures, so I'm just going to delete that. I also don't think I'm going to mess around with a hint this time. We sort of talked about that last time. Okay, so that's a little neater. Okay, so let's insert a text block where we can write our question. So here's where we'll write it. This is where we'll put the answer. Now, if you're going to randomize anything in Lon-Capa, what you need to do outside of any problem part is to put a Perl script block at the very top. So I'm going to insert a Perl script block, and you get this little thing. Okay. If you want to look at it through your XML, here's your script line. So just in between these two things, you can just type in whatever you want. Okay. We'll just go ahead and stick with edit though. Okay. So let me just go ahead and write a line or two, and then I'll talk about what I'm doing. Okay. So let's see. If we're doing a t-statistic, we'll need a mean. I'll say something like this. We'll need sample variance. Say okay. So let me go ahead and stop here and explain what I'm doing. All right. So this $sign right here. Okay, that indicates that it's a variable that's created by the user. Okay, so in this case, it's a variable that I'm creating by setting this equal to something. Okay, this ampersand, that indicates that you're about to start a built-in function. Okay, so this random function is something that's already built in. So how it works is you type in this part, and then you put in three numbers. You put in a lower bound, which I put at 40, an upper bound, which I put at 50, and what sort of increments you're going by. So in this case, 1. So x bar is going to be some random number. It'll be 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, or 50. It will not be something like 42 and a half. Okay? Now if I change that to 0.5, then it could go from 40 to 40.5 to 41, etc. We'll just leave it at 1. Okay? So notice that my sample variance, it's ranging from 1/2 to 2, and it's going in increments of 1/2. Okay? All right, so what else do they need if they're doing a t-statistic? They need an n, so let's do that. Say 15 to 25 by 1. Okay. Also notice that I'm ending every line with a semicolon. So when you're doing Perl script blocks, think SAS. Okay, you have to have the semicolon at the end of every line. Okay? Now, let's say we're going to do hypothesis testing. So I'm even going to randomize that. I'm going to say I've got a mu0 that's going to be different for every single student. Okay? Just to add one more layer of randomizing. Okay, so here, instead of just one function that I'm doing, I can do an equation. So I can do, say, x bar. So notice I still have to use the dollar sign to indicate that it's a random variable. Plus, I have to do now, now I'm going to do another random. Maybe I'll just have it be whatever x bar is plus something. Okay, something like that. Also, upon reflection, I think I'm going to widen that just a little bit. Okay. All right, so I've got that. Now there's one other thing that I have to do here, and that is I have to calculate my answer. Okay, so since every single student is going to get a different set of values, I'm going to have to calculate a different t-statistic for every single student. You cannot do that in the problem itself. You have to do any sort of calculations all within the script block up here. Okay, so I'm going to set my t is equal to, it'll be my x bar minus my mu0 divided by, and now there is a function called square root. So it'll be just square root of s2 divided by n. Okay, so don't forget your dollar signs, and don't forget your ampersands. Now you can do some simple arithmetic functions like divide and add and multiply, subtract, but you can't do something like that. You can't do squared. To do that, you have to apply another function, power, and then, so we want it squared, so we put the 2 in there. Okay, so something like that. Okay. Okay. So that's everything I think that we need for our script block. Okay, so now we can write a question in this text block. Okay, so we will say, suppose a sample of size n. Now, when I use that dollar sign, even though I'm out of the script block and I'm in a text block, it won't show dollar sign n. So this isn't necessarily a verbatim string. This dollar sign n will show whatever random value is shown in the script. Okay, so suppose you got this sample of size n. That yields a sample mean. Okay, now this is really neat. All right. So those of you who know LaTeX recognize what I'm doing here. This m/m means that everything in here is using LaTeX. So you could do anything in there you want, and it'll look very nice, very pretty. Or if you don't know LaTeX, you can also hit this Edit Math, and a little Java app will come up. And so, you can see, you can just sort of mess around with things, get whatever you want. But of course, if you know LaTeX, it's a lot simpler. Just type it in. Okay, so that's a very nice little thing. Okay, so x bar is equal to, and then this will give the actual value randomly selected from the script. Okay, and a sample variance of, again, I'm going to use LaTeX to make it look nice. We'll say s squared equal to that random variable I called s2. Okay, so I'll say calculate the t-statistic under the null hypothesis that, here again, mu is equal to mu 0. I believe I called it. Yeah, mu 0. Okay? Look good? Everything makes sense so far? So in this text block, I'm sort of making a combination of using LaTeX and pulling random values from the scripts to write my question. Okay. Now here, for my answer, I of course want it to be that which we calculated in the script, this t. Okay. All right. So let's save and view and see what we got. All right. So suppose sample blah 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 looks fine. And notice that LaTeX looks so pretty. It's very nice. All right. So this, however, does not look nice. I always forget to do this. So I'm going to show you another function that you'll just use all the time. And that is, so here I'm in XML, but it's the same thing. Notice here's my script block. So for my t, I want to round it, so I don't have 5 million decimal. So I use the function round2. So notice I use that ampersand again, round2, and then at the very end you say comma and however many decimal places you want it rounded to. So 2 will be fine, although I better put in the text box. Notice I've got it in the start out text, end out text. Round to 2 decimals will be fine. Okay. Okay. So all right. So this still yields a junky t, but whatever. It's just a tutorial. Who cares? Okay. So let's make sure that this is actually calculating this right. All right. So we've got all right. Sample size 21, 44, and 2.5. Okay, so we'll do, what are we doing? Oh, what was the mu 0? 45.5. Okay, so 44 minus 45.5 divided by square root of 2.5 divided by 21. Okay, fine. Negative 4.35. Beautiful. All right. It works. Hooray. Okay. So that is that's the basic randomization that you'll use. Let's take it a step further now and say you want your students to compute the p-value. Okay. So to do that, I'm going to do a couple things. First, I'm going to create an arguments list. Okay, so now I'm using that @ symbol. I'm going to call it args for arguments. And so when I use this @ symbol instead of the $sign, all of a sudden I can put in multiple values. So I can make a vector now. So in particular, I'll need to pass in my t, and I'll need to pass in my n. Okay, fine. So okay, so I've got this argument list. All right, now you do need the parentheses. That's important. Okay, so now I'm going to insert a new part. All right, call it part B. And all right, so first I'll enter in a text block, and I will say calculate the p-value. Okay, so here I'm going to insert a math response. Okay, here's where you can begin to implement R. Okay, so save and edit. Okay. Now there's actually two different systems that this can use. Okay. All right. So here's my question. Here's my math response. All right. So it can use maxima, or what I want is R. Okay. I need the argument array is that thing I wrote, args. Okay. And here's where I'll type in the code. Okay. First, I'm just going to delete this and save what I've done. Clean it up a little bit. Okay. All right. So here's how it works. Basically, you can type in whatever code you want, but also using semicolons. But here at the end, this needs to be a true or false statement. Okay, so basically, Lon-Capa determines whether you get the answer correct or whether you get the answer incorrect, based on whether the last line is true or false. Okay, so keep that in mind. All right, so if we want the students to calculate a p-value, then we might do something like this. All right, so we'll use this function in R. Okay, actually, before I start this, let me also say there's two things that you're working with, two vectors that are given in here. The first is Lon-Capa list, whatever item you've got. Okay, this list, automatically built in to be called Lon-Capa list, is this argument array. Okay, so in this case, I've got two items in here. So Lon-Capa list 1 is the T, and Lon-Capa list 2 is the N. Okay. The second thing that you've got is the built-in response vector, and that is what the students type in. Okay, so the students have their blank, and they'll type in something like either a single value or maybe multiple values, something like this. Okay, and so if this is what they type in, this line, then response 1 is equal to 1, response 2 is equal to 2, response 3 is equal to response 4, which is 3. Okay. All right. So that's what we have to work with. All right. So let's see how to do this. Okay. So degrees of freedom will be n-1. And since I made the absolute value, we'll just go ahead and say lower is equal to false. So that's just a little bit more generic than what we necessarily need in this case. Okay, so that's line 1. All right, so typically you also want some sort of tolerance built in. So say we want it 0.05 times whatever the answer is. Okay, so then typically your answer will look something like this. Okay, so what they put, the student, minus what the correct answer is, and if that's less than epsilon, then they get it right. So if this last statement is true, then students get it right. Okay, if it's false, then they get it wrong. Okay, pretty straightforward. Okay, so negative 1.77. And sample size of 24. Okay, so okay, so 0.045 should take it. Good, just like we wanted. All right, so notice, usually down here, Lon-Capa always gives you the answer for each part. For anything where you're using some sort of computer system, it's not going to give you an answer. I mean, I guess it could, but it would just say true, because that's essentially what your function gives Lon-Capa back. So I mean, it can't really give you the answer. All right. So okay, so we're good. You've got your argument list there, and then you've got your R code all up in here. Okay. Now, let's say we want to do one more thing. Let's say we want to see if they actually have any idea what they just did, and see if they know whether they should reject or fail to reject. Okay. So let's go back to edit. Since it's randomized, a lot of time that can be a little tricky. But again, we can implement some R by adding another math response. Okay, save and edit. Oh, I shouldn't have done that. Undo. Okay, because I need it to be a part, problem part. All right, see now it's happy. All right, we'll call it part C. Now we're adding a math response. Fine. Okay. Okay. Let me delete this hint. So I don't want it. It's just messy. Okay. So here we are. We've got part C, and we've got our math response. Okay. I'm going to, again, change it to R. Okay. And again, I have to pass it the argument list. Okay. So here, first we have to write a question, so I'll do that. So insert another text block. Okay, save and edit. Okay, so this is typically what you'll do in this sort of scenario. Okay, you will say, okay, something like that, whatever. Okay, then you'll have to give them very explicit instructions. Something like this. Now, they have to use the quotations. I mean, because essentially how you can manipulate this is that response is essentially going to be C, and then whatever the students put in that blank. Okay, so that's sort of how Lon-Capa is calculating this. So if you tell them to use quotation marks, then you've just passed in a string, which then you can compare to the correct answer. Okay, so we'll say, okay, so I'm just going to go back and copy some of the old code, all this mess. Okay, so if that p-value is less than 0.05, then we'll do something, else we'll do something else. Okay, and okay, so if it is less than 0.05, then we'll say answer is going to be a string that we'll call reject. And if it's not, then we'll set answer to some string fail, right? It has to match this exactly, of course. And you should know that. All right, so reject or fail. All right, and then fine. So then you just say is the answer equal to what they put? True or false? Okay. Okay. So that should work. Okay. So negative 3.39. That should reject pretty handily. Without actually looking at the p-value. So we'll see that. And you are correct. Hooray! Very good. Wonderful. Marvelous. And I think that that's all the randomization that I'm going to show this time around.